Bright Tuty. Every student matters.
Let us try some questions. Here, let's read which of the following are models of perpendicular lines. Starting with the A part, the adjacent edges of a tabletop. So if you notice, your tabletop probably must be in the shape of a rectangle. So the adjacent edges we see, so here this and this, these are the adjacent edges, right? So do you see which particular angle they are forming in between? They are forming a right angle which measures 90 degrees. So therefore, we can say that yes, the adjacent edges of a tabletop do model for perpendicular lines. So let's put a tick over here. Let's see what is given in part B. The lines segments forming the letter L. So the two line segments that form the letter L, one is the vertical line segment and the next one here is the horizontal line segment. And where they meet, they clearly make an angle of 90 degrees, right? So yes, this is again a model for perpendicular lines. Let's see what is given in part C. It says the letter V. Clearly, students, we see that in letter V, the angle formed is less compared to 90 degrees. Therefore, this particular letter V does not model for perpendicular lines. I hope this is clear. Let's move to the next question. It says, let line segment PQ be the perpendicular to the line segment XY. So the first thing that we need to draw is a line segment XY. So students, because I am using the rough hand to make these drawings, make sure that if you are trying, you use the ruler, pencil and draw straight lines. Okay. And you can use the protractors in order to draw the perpendiculars. Now, let us see that how we can draw the line segment PQ. So here it says that line segment PQ, let's say this here, this point is P and this point here is Q. This is perpendicular to the line segment XY. Let PQ and XY intersect at point A. So this point of intersection is A. They are asking us what is the measure of angle PAY, this particular angle. So clearly, because students, we know that line PQ is perpendicular to line XY. Therefore, the measure of angle PAY is equal to 90 degrees. In fact, if you see the measure of angle PAX, measure of angle XAQ, measure of angle YAQ, all of them measure 90 degrees. I hope this is clear. Moving on to the third question. There are two set squares in your box. What are the measures of the angles that are formed at their corners? Do they have any angle measure that is common? So in order to answer this question, I want you to see at these images. These are the two set squares that you will find in your geometry box. So if you are having your geometry box with you, I would suggest that you please open up your geometry box and see these set squares here. So here students, these set squares, they have certain angles at each of the corner. Look at the first one here. In this particular set square, this angle here is 90 degrees. This particular angle is 90 degrees. And here in the second one, this particular angle is 90 degrees. Now what is the measure of other angles? This particular triangle, this particular set square has got here this particular angle measuring 45 degrees. And this angle here is also 45 degrees in measure. Now let us look what are the measures of this particular second set square. So students, here the bigger angle that we see, this angle, it measures 60 degrees. And here the smaller angle, it measures 30 degrees. I hope this is clear how we can see 90 degrees angle in the set square. Now the question says that there are two set squares in your box. What are the measures of the angles that are formed at the corners? So we have written all the angles that are formed at the corner. Do they have any angle measure that is common? So yes, we can see 90-degree angle is common for both of these set squares, right? Now let us move ahead to question number 4. It says study the diagram. The line L is perpendicular to the line M. So you can see here this particular line, the horizontal one is line L, and this one here vertical one is line M. We need to answer the questions that are asked. So let's see the first one, the A part. It says is CE is equal to EG. So let's find out where CE is. So we can see here this is CE, right? Is this equal to EG? Right. So check this by counting the squares, counting the spaces in between. So let's see the number of jumps we'll make in order to reach from C to E. So it's 1 and 2 jumps. And let's see how many jumps are required to reach from E to G. So it's again 1 and 2. Therefore, we can clearly say that these two are equal. Okay. So we can say that yes, CE and EG, they are equal. Why? Because both of them measures 2 units each. Now let us move to the part B. It says, does PE bisect CG? So where is PE? Here this particular line, this point is E, and here this point is P. So we are basically talking about the line M, right, on which we have got these points P and E marked. We need to see, is this a bisector of CG? So here we have clearly seen that because CG here at point E is bisected, because here this is 2 units, right? And this is 2 units as well. So clearly, because PE is dividing this line segment CG into 2 equal parts, therefore it is a bisector of line CG. So again the answer goes yes. Now let's look at the C part. Identify any 2 line segments for which PE is perpendicular bisector. Okay, so let's see any of the 2 line segments for which PE is perpendicular bisector. One, we have already seen that PE is a perpendicular bisector to CG, right? So we can also see that PE is perpendicular bisector to, look at here, DF, 1 and 1 on both the sides of EP, right? So here this is PE is perpendicular bisector to DF, and let's say, because we have already talked about CG, so this time let's write for BH. Okay, so we have got that PE is a perpendicular bisector to these 2 line segments, because we were asked to write 2 line segments. Okay, we know that even though CG is a line segment which is being bisected by PE, but we are not writing it because we have already learned about this in the second example that we saw. Right, now let's move on to the D part. Are these true? Let's look at the first point given. It says AC is greater than FG. So where is AC? Here it is. It's of 2 units in measure, right? Now where is FG? So here this is FG. What is the measure of it? 1 unit. So is AC bigger than FG? The answer is yes. So the statement is true. Moving on to the second part. Is CD equal to GH? So look at CD, it's 1 unit in measure, and GH is again 1 unit in measure, right? So the statement is again true. Yes, they are equal. It says BC, so here it is BC, which is 1 unit. It's less than EH. So where is EH? Here it is, which measures 3 units. So definitely EH is bigger, and the statement is true again.